Apologies if I delay just a little bit early.
Yeah, that's fine. All right, thanks for coming. So the purpose of this little presentation is just to go through some basics of WDL and CWL. I know most people seem to have experience with CWL, so not so much WDL. I've got a little bit of experience with WDL, and I'll just go through and explain some basics. So let's... Okay. So why I started with WDL? So I was tasked with writing some GATK pipeline, a couple of them, and obviously Broad were the best people to go to, and they just happened to recommend WDL. Was probably because they were creating it, or they created it. It has got tutorials, it has got best practices, it has got forums, a forum for asking questions and real-world workflows. As you see down here, these are just some screenshots of the user guide and some already pre-made GATK workflows. If you have a look at these GATK workflows, they're somewhat more complicated than the example I'm giving, but I'm just showing a couple of basics for WDL. There's also a toolkit available, which is fairly useful. Toolkit allows you to perform a couple of functions like validate your syntax of your WDL file. It has a function which can create a config file for you. So once you have your WDL file, you read and validate it, you run the input, it's a JSON input, and it creates a JSON input file for you, all probably formatted with the correct file types and everything, and all you have to do is just replace the values for it. I'll give you a small example a bit later. And also for the non-programming, programming inclined individuals, there's a pipeline builder. So you can actually literally use the GUI to create inputs and then build the pipeline from the right over there, which is quite useful if you're not well versed in programming. The full specifications are here. The validating the syntax command is this one here, and I'll go through that a bit later. It also has reusable functions, so I'll go through that as well. It's called core aliasing. Is where basically you use the same function with different inputs to create the same output, so basically a reusable object. It's got the pipeline builder, and it's got scatter gather as well, which is basically, I'll go through it in a bit more detail in a bit. Now if we go to the basic overview, so the basic overview of a workflow, you have the workflow name, which is out here. It has a tasks, so it calls the tasks, which at top level is just defines the inputs to the task, and then the task itself contains the definition of the components, what commands are run, what the outputs are, and so forth. So a simple example, what we have here is we have our workflow, which is defined here, and we call hello. We call the task hello here, which has a command, and it has the output. And the basic output is just basically read in the variable name, and the output is print. So if we have a look at the JSON file, so the JSON file, you go test, so you got test, which is the name of the task, hello, which is, well, so test should be the name of the workflow, sorry. So test is the workflow, hello is the task, and the variable name is, well, the variable name is name, and the variable is world, so it passes the world into the name variable and prints it out at its most basic form. So what you can do is replace the echo, obviously, with any number of other commands, and it essentially acts as a shell for whatever command that you wish to use. So to talk about some basic plumbing. Plumbing, what they mean by plumbing, it may be the same as CWL, is it?
Pretty simple.
Pretty similar. So it's basically what steps the pipeline can take in terms of flow. So if you have the different steps, so you've got the step one was one component of the pipeline, you have the input and the output, which goes towards step B, and this is obviously called linear chaining. So if your pipeline consists of 3 or 4 different programs, with the output of one goes into the output of the second, into the output of the third, it's called linear chaining. There's also multi-input and multi-output, where you can have one step go into the second step, and if the second step has multiple outputs, it's fairly simple to place both those outputs into output or the step C. Something like this would be if you're using a tool like SAMtools and you have to create a sorted BAM file with an index for it. You can create both in the same command, output both the files, and input both those files into the next step fairly simply. Scatter, gather. So this, so basically when you have a number of files and you want to run them all, a number of sample files and FASTQ files, and you want to run them all at the same time, and eventually grab all the output at the end and put it to, and use it as the input of the second step. Scatter gather is what you use. I think I put this is the picture that they've put up, but I find this is quite difficult to sort of understand what's going on. It's essentially a number of, what probably would have been better if they had another image on the side of saying an array of samples which are scattered to the same step multiple times and then brought back together as a singular file the next step. So a basic overview of task aliasing, which is simply the sort of reusable methods. So what you can do is use the same method multiple times by just calling it something else. So this prevents any redundancy in writing multiple tasks out multiple times. So what we have is step A and step B. So if you're going to have the first sample and second sample, so step A is the name of the task, and you alias it by calling the as the second name. This will be explained a bit better on the next page. So when we have task aliasing, before we had the task of hello and the echo of the hello variable. For the workflow, when we're calling, we call hello as itself and hello as hello2. So it's the alias of that particular of the the task. And what you have in the workflow is the different variables. So it basically runs through the same task multiple times with different inputs, and it's a form of reducing the amount of code you have to write. So I'm just going to go through my example just quickly. My example is, what I do is I convert a number of FASTQ files to FASTA. I perform a small assembly with IDBA, I blast it, and I merge the output. There's 3 files for this. There's the Slurm job submitter, the WDL file, and the config file, which is the JSON file. So how to run the pipeline? The pipeline is run with this command here, and this is the config file. You can add a bunch of other parameters to it, but the main ones is basically the SPatch with the job name and the command or working directory, the output, and also the command, which is wrapped up in the script. You can set some default parameters, runtime minutes, CPUs, and memory, but these can also be set individually per task in the config file. So if we have a look, it should be on the next screen. Oh, well, this is the WDL file. I'll go to the JSON file next. So what you see is we have the workflow here. We have the scatter gather. Up here we have an array of files. So the text file, which we input into the script, is a 3-column file which has a sample name and two FASTQ files, paired in FASTQ files. And what you can see, it reads it into an array, and the scatter runs through input samples, which is the name of the array of files. And by using the location, you can print out, or you can use each FASTQ file. So what this does is cause this task, FASTQ-FA, which, if we look over here, is a full task. And what it does, it passes the input, FASTQ1, as a sample from the input file. Here, it merges them and creates an output. So for the output, we can set it as what we like, and set it as a sample name.faster, and we can set the runtime minutes. And then if we have a look for IDBA, by calling and chaining the output from the previous task, we just put FQ-FA, which is the name of the task, dot output faster, which is the file which is output. And you can chain together the output from one component, one step, to the next one fairly simply. So this continues on after, so it performs an assembly with an IDBA task, and then it performs blast. It copies the output to an output direction that we set, and then it calls another task outside after the scanner, which merges all the files together. And this is an example of the config file. So from here you can see you can set the global, similar to the global variables. So we've got the sample text file which I inserted. We've got the names of the programs and their locations, and basically the run parameters for each of the Slurm job submissions. So a running example. So if I cancel that, and I'll go into small. Okay. Example here. So here has the CROML jar file, the input file, a couple of FASTQ files, and a couple of other examples that I used for, I'm going to use to show some examples. So if we want to show, say, a syntax error, have a look at, where are we, PowerPoint. So the WDL tool, and we want to say validate the syntax. So we go inputs, validate, and then WDL. Yeah, the one negative with, well, one of the negatives for WDL, the example, the error messages aren't exactly very, informative. But this is a tool which is good to use to help you find as much of those areas as you can. Anyway, we'll go to the next part, which is just want to show the inputs. So to create a So this takes a working WDL file and creates the all the necessary inputs and outputs, or inputs for the different files and things inside the WDL file, which is fairly useful. And now if we just want to run the pipeline as an example. Let's see, what do I do? Oh, hang on, I should
Yeah, cutting the character showing there probably. You've got the com.
where was that? The Java config crom slam, that's right, just jar cromwell. Is it lowercase? Nope. What did I do?
You just refer to crossline without the dot dash, dot slash. You got crossline.
So without the dot slash? Nope.
Maybe the dash config. Dash D probably wasn't being copied properly.
Dash D config.
I think it's a copy thing.
Yeah, dash D config, I thought that was right. Well, it was working when I tested it. As always. Oops. Cromwell jar, run .dl pipe, seems right. Pretty sure it was there. Cromslam.conf, yep. Yep, that looks right, unless.
Try removing the dash from the D and then retype it yourself. Sometimes copy pasting from Windows. Give you some fun there. Okay, so now you need to change the dash jar as well.
Yeah.
That's there. I don't think.
Yeah, that looks like it, doesn't it? But,
Yeah, and you said dash I. The one at the end.
the one at the end as well.
Oh yeah, the WDL. Yep. Okay.
Yep, that's it. Thanks very much. So this just shows a simple example of it, running through the pipeline. So it might take a couple of minutes to run. So if there's any questions so far about. It's simple to start off. There's a lot more complicated examples, but I haven't necessarily needed to go into those at the moment. Yeah, I mean, to start up and run something, it's quite simple to start up and get a job running fairly quickly. It has got other functionality which I haven't used, which is the resume, which can be useful. It doesn't just work with Slurms, it works with the SunGrid engine and also PBS as well, I think it is. So it works with a number of different backends. I suppose in terms of portability, which is one of the bigger issues, I'm not sure whether. So I mean, we have to work within our server environment, which is loading up the modules. So that would be a difficulty moving the pipeline to other areas. So, but I mean, I'm sure if
I
someone.
had someone tell me that it wasn't working on PBS Pro, but then I quickly looked it up and there was some evidence that it was,
No, it technically,
variants of PPS.
yeah.
So I want to work on some variants and not others.
I mean, technically, it wasn't supposed to be working on Sloan either, but it's just required a few changes to the actual config, and because it was actually made for subgrid engine, and yeah, it worked fine. So it may just need someone to sit down and figure it out exactly what's going on. When, yeah.
Does anyone else work on the NCR cluster in Canberra?
So it actually works with our group in Melbourne Integrated Genomics, especially in CWL Basics Presentation. So your interests are, you want to tell everyone about your interests, and then you guys can tell about their interests as well, and see if there's any sort of intersection.
Yeah, so the National Centre for Indigenous Genomics, we've sequenced genomic DNA from now hundreds of people, and we've run that through a pretty standard BWHGTK 3.8 pipeline to core variants, mapping onto GRCH38, struggling to know how to deal with block contigs properly, and yeah, so all of our scripts are just written in just shell scripts, which we just execute in a
Sequential
order. Yeah, it's PBS Pro. There are, I guess, I'm not too experienced in the different cluster operating systems, but I guess they've tweaked it a fair bit up there. It's a very particular cluster that gets used a lot by the Bureau of Meteorology and other places, so it's not set up for bioinformaticians in mind.
Yeah.
But it works. They are very reluctant to have any job run past 48 hours wall time, which sometimes is a pain in the ass, but
Would that be using something like this, which submits each of the jobs individually, then they'll get around to submitting the 40-hour war time for each job submission, wouldn't it? So the way that this works is instead of submitting the whole pipeline at once and saying it has to run within 48 hours, it submits a separate S-batch job for each component, for each sample. So I can open up the, let's see.
Well, really, are you doing whole genomes?
yes. So some of the BWA commands with like 100x coverage.
Yeah, and if you run like collar, whole genomes sequencing, without doing parallelization, you probably easily could be on 48 hours in some cases.
We break it up into 44 genome intervals, which deals with that.
Kind of have to.
Okay, this has gracefully shut down. Was there an error? No, yeah, there was too. I think I'd already run the output file for it before.
Merge.
Yeah, the merge.
So I'm happy to take feedback, right? Like what we've written at the minute is essentially sort of a hack. It works, but we want something that's usable by people for years to come. We want to be able to rerun the analysis pretty easily as new samples come in.
I mean, that is a good thing for Cromwell, is that it's submitting jobs. It's not kind of running the whole pipeline at once. It can do the scatters, and it all splits up into lots of different jobs. Whereas we did some tests on Amazon, and if you're using Amazon Batch, like it will submit one job to Amazon Batch, and if it can run as many of the jobs as it can inside that container. Use Docker up in AWS, and then if you run out of, so Batch is a bidding system. If you kind of fall below your bid, it will just hold all the jobs until you can get new kind of instances, and then we'll just run them all again. So you're not kind of locked into a time frame or things like that. And if you just provide more resources, then it's just happy to consume more instances.
Yeah, so I had run it yesterday as a test, and it was in the output. So it failed because there was already the output file there. But yeah, that's essentially how it runs. I think in terms of Ashley's work, are you going to require? So one thing we want to do is try to come up with a standard which obviously has the usability of both CWL and WDL, and also has the portability. So we're not quite sure. So are you going to be using it completely on the ANU cluster, or do you want other users around Australia to be able to use the same pipeline? So one of the issues we're having is, so with this, if I was to port this to another cluster, I have to look up how they load their modules and so forth. So we're trying to sort of come together, and you guys have already started a project on creating a system which they call Shepherd, which incorporates multiple workflow languages and also has portability. So once we create these pipelines, we can easily port it from cluster to cluster and run the job, the same job over and over again. So I think that's the type of thing that we're trying to aim to do here. It sound useful?
My interest is less in portability because we don't want to move off that cluster, and it seems like there's long-term support for that machine. Our interest is in rerunning it over and over and over, and then exactly what the
Pipeline does.
pipeline does. We want to be able to come in and out at different points in a way that non-computer scientists can easily get their head around.
So that's one interesting point that I haven't really looked at. Multiple entry points for. I'm not sure if WDL has multiple entry points for the same scripts, or whether it's multiple pipelines for. So say if I was doing this and I wanted to, if I've already got the assembled contigs, would I be able to go in at the blast stage as opposed to having to run?
I don't believe Cromwell at the moment allows that. It does allow caching. Like it says somewhere in the documentation that if you upload a job that's already partially run, it might be able to tell by your hashes that I've already done this thing, but I haven't been able to replicate it.
Okay. Yeah. So it may be that we might have to, instead of creating multiple entry points, we may have to create multiple pipelines that are portions of that original pipeline to run at different stages. So in the JSK version, you can have one which runs from fast queue to GCVF and core various merge, or one which runs just the BAM files. So you basically make BAM files and you store those BAM files, and then another entry point for BAM files to another, say, combine a VCF and so forth. So you may need, I think that's another sort of thing that we're going to probably have to look at.
I'm going to go and see what their default pipelines are on the road.
Yeah.
See whether it's compatible. See how much work it is just to try it out.
That should.
The biggest thing that we had to get our heads around was that, depending on file sizes and memories, and there's all these quirks in the cluster, right? Like some jobs will just fail on some compute nodes for reasons that we can't understand.
Yeah. So
you get partially completed files, and you can't work off whether the file exists or not. You've got to go off the exit status of the previous step and deal with all that properly.
Yeah. So the error reporting system, it does have some. So if we have a look at what went wrong with this one. Yeah, it's not the greatest error reporting system. It does tell you where it went wrong, but so it just says the input file is the output file.
And that's the error message from CAT.
From CAT, yeah.
Yeah,
Okay.
so
Well, that's
it's
right.
just returning whatever, like SE, as if there's an exit code, it's just dumping the whole console into that file.
Yeah.
And if it does return an exit code of 0, you can still get SE out and have a look at, step by step. It's like, has this actually succeeded, or has the tool returned a successful code, but it's actually failed somewhere? And Cromwell pretty aggressively fails if it detects something isn't right. It's like, I'm stopping the workflow, I'm not doing anything more. And you can, in the server mode of Cromwell, and in this one as well, you can get a full graph of kind of what has happened, like the timing of everything, when things are starting and stopping, and you can collect your big logs of outputs as well. So it's pretty upfront with what information it has.
Are you going to show something like that? Or?
I'm not sure. Yeah, not trying Cromwell. Just the same workflow as CWL. But from my experimentation from this as well, you can open up.
Presumably you can specify resources per job step.
So you mean, what do you mean by digital resources? Like,
Well, if you're doing a trim, for example, you only want one CPU and a small amount of memory.
Yeah. Oh yeah, sorry. Yeah, that was the Yeah. So they have different. You can set the default, and if you want to set separate steps of the IDBA output, they're all practically the same, but you can change it. So the merge run, obviously, it's a cat command, so it doesn't need as much resources as the other ones.
Right.
So you can set the individual.
Can you wrap that up in a workflow itself? Presumably you're going to have to write a different config if you're using a different batch system or it's using the same config.
So
You can declare them on the tools as well. You can pass inputs through and they can either flow through the workflow, or you can declare them on the tool as runtime attributes, which are passed, I believe, by Nspatch.
yeah, it's passed by Nspatch. So
So in your
this.
Slurm config, that will pass a lot of those options you provide.
Right. The Slurm config, that's
So the Slurm
Ah,
config
so-
is
yeah,
this
so
one
what-
here.
So that's not a WDL thing, that's a Cromwell thing.
Okay.
So the Cromwell Slurm config has the SBatch, so it just creates the SBatch, it wraps it up in a Slurm script, and the default parameters, runtime attributes, can be found here. So if I send the task, so this is the default. It reads the parameters from the JSON. So the JSON file sends it to the WDL. The WDL sends the command and the runtime attributes to the Slurm, the Cromwell config, which passes on to Slurm. So here, if we have a look at FQ to FA, passes the 40 gigs of RAM, the runtime minutes, and the threads. That gets called here, and then that is all wrapped up. The command, the output, and the runtime is wrapped up and sent to here, creating a script, and then submitted to Slurm.
So it looks like you can fairly easily write your own back end as well.
Yeah. They provide like a bunch of default configs.
Yeah.
That you can pretty much write whatever you want as long as it plays correctly.
Yeah, so you just pass them a Java class.
Presumably.
Okay. Do you want to give your CWL?
Yeah.
Yeah. So I think you just have to. You're on laptop, I think. Let's see if I can switch to see yours. That's yours, yeah.
Where is this? Cool. So, CWL is another workflow language. It's more of a declarative one. So that's the front page from it. It's got a user guide with tutorials, a spec. The main two parts of CWL is you have the workflow specification, and then you have a command line tool. So this is pretty similar to a task and your workflow. So why use CWL? It's kind of goals, I guess, were to achieve a common specification for workflows. It's open source, so anyone can commit to it. They still keep a fairly tight control on it, but you can see everything. Their discussions are fairly open, so you can always kind of dig into the community and get involved. There's lots of engines that support CWL. So Cromwell is one